Hi, my name is Amber, and this is the Module 6 experiment. So first, the water and the food dye. So in cold water, the food coloring drops to the bottom of the glass almost instantaneously. There's only minimal swirling in the water of the dye. In contrast, the dye with the hot water spreads out very quickly. In the hot water, there were swirls at first, but they went away pretty quickly as the dye mixed with the water. The hot water dye spread much quicker than the dye in the cold water. This difference was very apparent, so I would say it was a big difference. Next, the experiment with the hot and cold vinegar samples. First, I added baking soda to the warm vinegar, which caused bubbles to form very quickly, and the reaction seemed much more violent than what I experienced in previous experiments. In comparison, adding the baking soda to the cold vinegar sample, the bubbles formed much more slowly, and the reaction was overall pretty slow, not near as violent as the hot vinegar reaction was. Ultimately, the hot water caused the dye to spread out more quickly than the cold water. In addition, the hot vinegar reaction produced the fastest rate of bubble formation in contrast with the cold vinegar. These results indicate that the number of collisions and the energy of those collisions are both higher in hotter temperatures than they would be in a colder temperature. This is impactful to my life since it explains how to make a successful reaction take place in the most efficient and in the fastest way possible. Knowing that a reaction happens quicker at hotter temperatures explains many everyday happenings, such as when you dissolve salt in water, which you can dissolve more salt at a quicker rate by heating up the mixture on a stove, for example, or how you can steep tea leaves much quicker and stronger in water that's hot than water that's cold or simply at room temperature.